Okay, morning everybody. Welcome to the class, and I'm excited to teach this elective class to everybody. I know there's generally two reasons you want to go for elective class. One is you need this 3 credit to get a degree, right? That's reasonable. There's other part of reason is I'm genuinely excited about X-ray. So I'm going to offer you guys 2 ways to achieve, right? It depends on what you need, what your interests are. So I designed the class such that I'm more target for everybody to learn about technique. I'm more interested in teaching everybody master the tools than really fill you guys with boring equations. So let me first use the first class to talk to everybody about what the scope and what the cost is going to look like, and what's the expectation from me and from you guys, okay? So first, if you haven't got this book, please get one. It's really well written and has a really good price. I don't think there's many textbooks at $40 last time I checked, right? So this will help you to get up to the speed, and I will assign readings throughout the class. I'm not going to go through the old syllabus because it's basically the same. Everybody, you saw the syllabus, it's pretty much the template. But let me emphasize the important part of the syllabus. So the teaching going to be 3 parts, okay? I designed such that we're going to have 3 portions of it. The first part is the most difficult one. Think about you go out for a 10K run. The first 15 minutes is going to be most challenging. Once you get up to the speed, once you hold a steady pace, this other 2/3 is going to be easy. So the first part, we're going to cover most of the things in this textbook. And I'll try to be selective, try to make it easy for those of you who are interested in more in the fundamentals than really stick to a lot of equations, because that can be a little bit challenging to comprehend in a short time, but I'll still teach those equations if you're interested, okay? Those are the fundamentals, how you understand how the polymers or generally material interact with atoms, all right? There's some part of the equation have it. Then we're going to go through the portion of 2. Once you learn all the basics, the next part I'll keep it practical. I'll give you guys teach science case-based scattering. We're going to go through a couple science case where you commonly see X-ray being used. So we're going to study a few science example. Let's say block of polymer assembly. I know something like Mark's interested in. A block polymer elastomer that Kyle might be interested in, or in other cases where you see crystal impacting or dispersion in the composite material. We're going to go through all these case by case. I'll explain what is a common study people do, and what is the typical finding people found, and what is the typical data analysis look like. Okay, it's going to be practical. So for me to better help you guys for section 2, we got 2-3 weeks. I hope everybody can do an exercise with me called scientific proposal writing. I don't need to be long. I send everybody an example at the canvas. So it's just about 3 pages long. Describe where your interest use X-rays are. And I've already posted something, a template there. Quite short. That's typically geared towards what you would do if you go to a bigger user facility. Let's say at the end of the day you might find an inspiration and you want to go to Berkeley or Argonne to do more advanced experiment. That's typically what they require, is write a proposal to us. So I'm going to help you guys go through the proposal process. And with that, it serves 2 purposes. First, help me to understand what your science case are, so that we can better prepare for the last third of this class's hands-on experience, practical experience. We're going to load your samples to really measure them and help you analyze the data, okay? The other part is help you. Let's say one day you might want to go for a major user facility. That's actually a good milestone for you. And I'm planning to have one scientist maybe as a guest speaker in the later part of the lecture, so that you can direct the talk to them about your science case if you're ever interested to submit a proposal, okay? So that's kind of a general landscape, how I designed the course. So the first part is the most challenging one. If you never run 5K or 10K, it's going to be a little bit difficult, but trust me, that's something you needed to get up to the speed. The second part will be more, I would say, more easier based on all the proposed feedbacks. I'll design such that I can group those interests and give you guys scientific example, okay? So this roughly maybe some time frame of late September to mid-October or something like that. Then we have late October to November for you guys to do hands-on learnings. We're going to go to the instrument, and we will, depend on how much research area and interest, we might cluster a couple examples. If they use the similar techniques, then we can run one by one, okay? So that's the general scope of the course. Any questions so far? And there's not going to be much homework for this class. Unfortunately, it's harder to do that, but I will make an assignment for you guys to read, and we will get a couple quizzes. And the idea of the quizzes is mostly centered around how you guys comprehend those basic concepts. Okay, no equation, no numerical questions, etc. But this is for me to get a feedback from you guys, how you guys gauge on the scattering portion of it. So that's the general scope of the course from now to roughly mid-November for this course. And the other part is we're going to design the course such that we're going to lecture 3 courses. Then our stage 1 courses for reading and question and answer. So that we will have Tuesday, Tuesday, then we'll have a little pause or question time. Because I think when I designed course, we were originally thinking about 2 credits. That's what typically elective courses are. But I understand that some of you need 3 credits, so we beefed up a little bit so that you don't need to take another elective courses. But we do have room for questions and go into deeper in some of the context. Okay, so any question for this part so far? Okay, good. So let's have a check. How many of you already had the book? I see most of you. If you have not, please go ahead and order. It's not particularly expensive, okay? So let's take a look. I'll walk you through one more thing, then we're going to call it the end of the first class. So let's go through the context. I'll help you guys explain what the contexts are, okay? So if you go to the content at the first few pages, we're going to generally follow the content of this class. At the beginning, we're going to do some introduction of the X-ray and overview. So this going to covers everything relevant to instrumentation of the X-ray, what X-ray is going through, and how does the material interact with the X-ray. So those are all the fundamentals. Those are important when you design experiment. Okay, we're going to go through immediately this Thursday about these interaction and introduction in the X-ray. I will please.
Dane's wondering if you're going to get the Zoom link up.
So I'm going to record the class and I'll send him a link.
Okay, I'll
yeah, you can if he prefers use the Zoom, we can set up that synchronous teaching for him as well. So I'm going to post the lecture notes before the class on Canvas. So I'm sure everybody are already pretty familiar with Canvas, right? You should be by now. So it's there, and you can go there and take a look at the lecture notes. it's going to be developed mostly based on this textbook. Okay? So, as you can see, the overview just to give you some guys basic ideas what scattering is and how it fits in the general concepts of morphology calculation. How does it relevant to the microscopy technique and others you're going to see. So the really tough one is section 2. If you read the title, this says basic scattering by particles. This is where all the complex equations, etc. you're going to see relate to scattering. If you found trouble reading this, don't worry about that. I'll explain to most the simple layman's term so that get everybody on board. I would say this is most difficult, and we're probably going to spend 2-3 weeks on this topic, talking about how scattering happens from a very simple single atoms to moleculars to more complex polymers, etc. Okay? And there's a lot of jargons here as well. If you look at Guinea region, polar region, you might be wondering what are these. Those are just some of the jargons people speak in their expertise field. You need to know a little bit of these. Okay, so this is I would call the first one sort of the class. Although it's only 2 chapters, but I think for chapter 2 we're going to spend a little bit slower time to go through all these, okay? Then science case 3 and 4 are both relevant, 3, 4, 5. Those are most relevant to the science example. We're going to explain what is different level of orders, short range and long range. We're going to go through all kind of ordering. And this goes from weak ordering, local polymer, phase separated systems, to more complex diffraction physics, which is polymer crystals, okay? After that, then we're going to really go through some of the scientific cases. If you already see it in 5, they already listed some of the example here. We may not stick to that based on all the feedbacks I got from everybody, what the material system you are interested. So we might modernize this part by looking at some recent scientific publications, pull papers in your field, then study it together and use that as example, okay? The part 6 is optional. It either, if we have time, it would be good to do it. If not, we will just skip it about that. It's about interfaces. It's not a strict, it is a subfield of scattering. It's more relevant to reflectivity. It studies the thin film interfaces, so it will be slightly different. So that's going to give you a good idea what is the class is about. And I think the other part that everybody cares about is how do we grade the class. I think in the syllabus we mentioned there's attendance requirement, so make sure you attend the class in time. I know early morning class is always difficult, but I amazed everybody showed almost on time today. Everyone, good job. So you guys are all going to score that 20 or 30%, whatever that percentage is. Make sure you continue to do that when the sun starts to rise later, to the later semester. It's going to be difficult, right? But in the later time, when we finish all the lecture parts, go to the lab part, we can be a little bit more flexible. We don't need to meet exactly at 8 a.m. to do lab-based training. So when we go into the lab session, we can later follow on what the time works best for everybody's schedule. Okay? And what else? We're going to have some quizzes and a lab report. That's basically, at the end of the day, I hope to see a short report talking about material system. You study to use X-ray and what's your understanding of that. Okay? It ties into initially the proposal, later to a short. I don't need a long, maybe just 2 pages is good enough for me, just to give me some understanding about how much you learn about in this class and what feedback I can give you. Then there's a final exam. The exam is mostly on the conceptual part. I'll give, it's okay. I have my alarms go off randomly as well. Where are you? Oh, we are talking about final exam. I will mostly test the 2 parts I'll give you up front. The first part is conceptual, relevant to the quizzes we do, because I do want to make sure you guys are on the board, understand the most fundamental parts of these courses. Then there is 1, maybe 2 examples of scattering data. I hope you can resolve it and understand what the scattering is studying and what is able to enable what type of science. Okay? So that's an overview of the class. Now it's a question you guys for me. Okay, for you to ask me. Anything? Is it clear to you what the scopes are and what the contents are? And the objective is, at the end of the day, I hope you really make this class useful. I hope you can adopt these techniques to your future scientific endeavor. Either you being a manager, you know what you can delegate your technicians to do, what the technique is capable of studying, or in your graduate school you would find it's useful to help you work on your thesis. Okay? All right. So if there's no more question, please, Lena. I love questions.
I was just wondering, for the proposal, when would you like that to be returned to you?
So I initially think about 2 to 3 weeks from now. Is it enough for everybody? I don't think I need that until we go to the second part of the lecture, which is more on the science case discovery. In the first part, we're only going to talk about basic of scattering. I don't need to read that. Is that a reasonable time frame for everybody to think about? And I post examples. So what the proposal looks like is, first is a general, maybe 2/3 of a page about what fields you are, what the challenge you're studying, and why scattering is important to you. Then it goes down to what scattering experiment you're trying to do, and what sample you are trying to measure, and what science you're trying to solve. And then later is just a few details about scientific experiment. If it's not clear to you, you can just try to give it a first pass. Write down what is the science problem you're trying to solve. If there's some technical detail you're not familiar with the X-ray, it's fine for now. Okay. And you can always reach out to me, ask a question. But I do post the example proposal we sent to Berkeley a couple years back and got award of time. You can read that and use that as a template to develop your own. Okay? It should be already up there. Sounds good? I'll update. I think I put the due days in about 2 weeks in there. If you find difficulty, just message me, okay? Otherwise, you can just message me and let's take a look at this work.
Would you like those emailed to you or delivered in person?
Whatever you like.
Okay.
I'm flexible in that. If you want hand delivered to me, that's fine as well. All right. Either way, Canvas, emails, hand deliver, or if you want FedEx to my home, that works. Okay, so any other question for the course? I think the other part, I'll make myself available in the meetings if you have questions, because as I mentioned, when you study the fundamental scattering part, I really hope you can hold your breath and follow me in this direction, because that's generally the most difficult part that confuses people. Why there are so many differential equations there, that scares people away if they're not familiar with it. Okay? If not, then let's finish this first part of class. And usually I would like students introduce to me what their interests are, but I think I already know most of you. I know what you guys are studying on, so let's skip that part. Okay? All right, if no more question, let's assemble on this Thursday, and we're gonna begin our real class, lecture 1. And I'll update my lecture notes on the Canvas, so make sure you follow up on that. And otherwise, I'll see you all on Thursday at 8 a.m. Okay? Sounds good?
Thank you.